Hai and Assalamualaikum. My friends and I from the group Anak Kesayangan Madam ini will be presenting the applied maximum and minimum problem. I am Narasha Sleha and I will be explaining about differentiation and how to apply the method. Differentiation can be defined as a derivative of a function with respect to an independent variable. In calculus, differentiation can be applied to measure the function per unit change in the independent variable. You may be wondering, when do we apply differentiation? Well, differentiation are applied when determining the increasing or decreasing of a function. It is also used to determine the speed or distance of a moving object. In this topic, the derivative is used to find the maximum and minimum value of a particular function. In the application of differentiation topic, there are 5 subtopics that students need to understand. In order: related rates, analysis of function 1, analysis of function 2, Rolle's theorem and mean value, and applied maximum and minimum problems, which we will be talking about in the next slide. What are applied maximum and minimum problems? Applied maximum and minimum problem is a method or a process of finding the maximum or minimum values that are called optimization. For example, finding the maximum profit in a company or the minimum of the cost, or find the least amount of material to make a particular object. How do we solve the applied maximum and minimum problems? Well, there are a few steps we can follow to find a solution. The first step would be to find the derivative. The second step would be to let the derivative that equals to 0 find the values of the variables. Next, we would have to do the second derivative test. If the result of the second derivative test shows that it is more than 0, then it is a minimum value. But if the second derivative test shows that it is less than 0, then it is a maximum value.
A rectangle fish pond with an area of 60 meter square is surrounded by a flower border with 3 meter wide on two sides and 2 meter wide on the other sides as shown as in figure above. Let x and y be length and width of the fish pond respectively. So the question say a rectangle fish pond with an area of 60 meter square is surrounded by a flower border with 3 meter wide. So this is 3 meter wide and 2 meter. We know that the fish pond area is 60 meter square. So the length is x multiplied with y. So this is the area for the fish pond, and we know that the fish pond is already 60. So basically 60 meter square equals to xy. So we already have the length and the width. Now we get to y plus 4 and x plus 6. So the combined area equals to, now we just multiply, we got sy plus 4x plus 6y. Okay. So we have to substitute the variable. Now we use to 60 equal to xy. We let y equals to 60 over x. We're going to substitute this equation. We just simplify and simplify again. And this is the answer. Okay, and next we will differentiate the combined area. So the equation for the combined area is A equal to 4x plus 360 over x plus 84. Gonna to A equals to 4x plus 300x to the power of negative 1 plus 84. Differentiate A over dx equals to 4 plus negative 1. And don't forget to multiply with 360x negative 1 plus 0. So negative 160 is negative 2. So 4 minus with 300 over s square. So we're gonna let dA over dx to do 0. So 4 minus 360 over x square equals to 0. Alright, and then we simplify, make go -4 to another side, and then negative 360 over -4 over x square, and then we got x square equals to 90, and answer will be x equals to plus minus 9.487. So this is the maximum or minimum value. We have to do second derivative dA over dx equals to 0 minus with -2, multiply with 360 x to the power of -2 minus 1, 720 x to the power -3. So 720 over x. So the second derivative, if we're gonna get 0.843 is more than 0. 0.843 equals more than 0. So the minimum value. So the minimum value for s is 9.487. So we're gonna to get the y. We're gonna to substitute x to fishbone area formula. Y equals to 60 over 9.487. We're gonna get y equals to 6.324. Okay, so the answer will be the x is 9.487 meter and y is 6.324 meter. So in the question C, they want minimum combined area, which means that the x and y value must be the minimum value. Now we just substitute the x value into the formula. So we're going to get A equals to 4, multiply with 9.487 plus 360 over 9.487 plus 84. So the answer will get 159.895 meters square.
Conclusion is, this method is exceptional, useful and beneficial in dealing with business or other difficulties which need calculation in our solution. First, apply maximum and minimum problems closely relate with the concept of application of differentiation. Second, the most crucial part is when analyzing the problem after accumulating the information. Next, find the derivative and let the derivative equal to 0 find the variable value. Then, use the second derivative to find out whether it's a maximum or minimum value. Lastly, substitute the value into the equation. That's all from our group. Thank you.